7.1. Apply the Pythagorean theorem. Pythagorean triple. A Pythagorean triple is three positive numbers and they must be whole numbers, so let's write integers that make this true. A squared plus b squared equals c squared. One of the triples commonly known is 3, 4, and 5, because 3 squared plus 4 squared, 9 plus 16, equals 5 squared, or 25. So that is one right triangle. So a Pythagorean triple are three positive integers that make a right triangle. Now, you should remember the Pythagorean theorem. It says in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. We represent the sides by A and B and the hypotenuse by C. Remember, the hypotenuse, C, is always across from the right angle. It doesn't matter which one is A and which one is B. So those can be interchangeable, but C has to be across from the right triangle. It's also the longest side. So let's look at example 1. Find the length of the hypotenuse of a right triangle. So we write down the formula. Hypotenuse equals leg squared plus leg squared. We substitute in for what we know. 24 squared plus 7 squared. We go ahead and do the math with that, which is 49 and, let's see, 576. We add those together to get 625. And then to get rid of a square on this side, we take the square root of both sides, and that gives us x equals 25. Okay, checkpoint. Find the length of the hypotenuse. So do this one just like we did the one above, and then start the video again when you're through. Example 2. A 6-foot board rests under a doorknob, and the base of the board is 5 feet away from the bottom of the door. Approximately how high above the ground is the doorknob? Well, if you're giving just this story problem without a picture, make sure you draw the picture first. Okay, but we do have the picture over here. So what do we have? We have a side, and then we have the hypotenuse across from the right angle. So again, we write down our formula. We substitute for what we know. 6 squared equals 5 squared plus something squared. We work these out into numbers. And then we need to subtract the 25 to get the x squared by itself. So 36 minus 25 is 11. And then we need to take the square root of 11 to get x by itself. And then it says over here in the box that in real-world applications, it's usually appropriate to use a calculator, and you round the answer to the nearest tenth. So our answer should be 3.3. Okay, again, go ahead and do this problem just like you did the one above, and start the video again when you're done. Find the area of the isosceles triangle with side lengths 16, 17, and 17. Okay, draw a sketch. By definition, the length of an altitude, which is the height of the triangle, and it on this picture, it is labeled h for the height. And let's go ahead and put height in here. In an isosceles triangle, the altitude of the base is also perpendicular bisector. Okay, now let's review since we skipped some chapters. isosceles triangle means two sides are the same. So this side and this side both equal 17. If I draw a line straight down from the tip, I'll have a right angle here. And this is perpendicular, and this also bisects this bottom line. So remember up here it told me it was 16, so that means that each of these sides are 8. Now I have two right triangles with side lengths of 8x and then hypotenuse 17. So I can figure out what the x is by subtracting. So I'm going to come here down here to step 2 and fill in what I know. So 17 squared equals 8 squared plus something. 17 squared is 289. 8 squared is 64. So I need to subtract the 64 from the 289. And that gives me 225. I need to take the square root of both, and so I get h is 15. Does that make sense? Yes, because we know that the hypotenuse has to be the long side, so this side needs to be smaller than 17. But I can see from the diagram that it's bigger than 8. So 15 fits in there well. Now, is that what I want to know? No. That just tells me the height of the triangle. What did the problem tell us to do? Well, let's go back and read it again. It says, find the area. So I need to put it in the area formula. So area is 1/2 of the base. Remember, the whole base of the triangle was 16, and the height we found was 15. So we can multiply this half times any of these numbers, or I can multiply first, but it's easier to say half of 16, isn't it? So half of 16 is 8, and 15 times 8 is 120. So the triangle is about 120, and make sure you put units on it, square meters. Okay, let's look at some common Pythagorean triples. Like I said, the most common one is 3, 4, 5. Now if we take 3, 4, 5 and multiply all these numbers by 2, we get this one, 6, 8, 10. We multiply 3, 4, 5 by 3, we get 9, 12, and 15. The second most common one is 5, 12, and 13. Now, I could sit here and memorize these, but it's really faster for me to go ahead and use the Pythagorean theorem. Okay, sorry I got interrupted. So I don't know how much of this thought that I finished, but what I meant to say was I could use the Pythagorean triples to find out most of the triangles, but it's easier for me not to memorize and just use the Pythagorean theorem. So you can do the same. Okay, it says example 4. Find the length of the hypotenuse of the right triangle. And you can use the Pythagorean triple. Now, like I said, I don't really have all these memorized, so I go ahead and use method 2. And you can do that if you want to also. So what do we have? Here we have 2 legs, don't we? Because the unknown side is across from the right triangle. And so we don't know the hypotenuse. So we just take 24, we square it, and we add 45 squared to it. And that gets us 2,601. Then we take the square root, and it's 51. So the side is 51. Okay, checkpoint. Go ahead and do these two. Again, on 4, I don't care whether you use the Pythagorean triple, although this one might jump out at you, so it might be easier to use the triple. Now, before you stop, let me come over here and draw the Pythagorean theorem for you. just to make sure you really understand this. So let's draw a right triangle. Let's put 3 on this side. Let's put 5 on this side. 1, 2, 3, 4, 5. And let's figure out what the other side would be. Not 5. Let's put 4 on that side. So I need to erase this and kind of start over. Okay, let's call that 4. So for the 3, let's draw a square here. So when it says square the sides, this is actually what we're doing. We're drawing a square with that many blocks in it. And then we count the blocks, and how many do we have? We have 9 blocks. Do the same thing here. Let's draw a square. Doesn't look very pretty since I drew it kind of wrong. But how many blocks do we have? 4 times 4. That's squaring 4. We have 16. Now if we add those together, we get 9 plus 16 is 25. And what that means is that now we have a square for the hypotenuse that has 25 on the side. And then when we take the square root, we're actually just taking a side length. So square root means the side of a square. And counting how many of those are, that's 5. Because 3 squared plus 4 squared equals 5 squared, the Pythagorean theorem.